Hey, fourth graders, it's Mrs. Spears. I'm going to do lesson 12.9 with you. It's a problem solving lesson about elapsed time. Now, elapsed is just a fancy word that means like how much time has gone by. So this is something that can be a little bit challenging sometimes if we really have to think it through. So I'm going to do these word problems with you so that you have an idea of how to work through them on your own. So the problem says, Dora and her brother Kyle spent 1 hour and 35 minutes doing yard work. They stopped for lunch at 1:20. At what time did they start doing yard work? Use the graphic organizer to help you solve the problem. So what do we need to find? We need to find the time that Dora and Kyle, let's see here, at what time did they start? What time did they start? So we need to find what time they started working. I need to use the finish time, or wait, the total time, I guess, the total time, and the time that they finished. Those two pieces of information will help me get what I need. And how will I use the information? I can draw a timeline to help me count backward and find the start. So they actually drew it out for you. Says, I draw a timeline that shows the end time 1:20 p.m. Next, I count backward 1 hour and then 5 minutes at a time until I have 35 minutes. So they finished at 1:20 and it said they worked for 1 hour and 35 minutes. So when you're trying to find time, go by hours and then minutes is probably is what my brain usually does when I'm trying to find elapsed time. So with these guys, what they did is they went back 1 whole hour because they had 1 hour and 35 minutes. So 1 whole hour back from 1:20 would be back to 12:20. It's the same minutes because going back 1 hour gets you at the same minute spot, but it's in the hour before, which is the 12 o'clock hour. So it would be 12:20 is 1 hour back. And then 35 minutes, they actually count by fives for you. So 5, 10, 15, 20, 25, 30, 35 takes you back at 11:45 a.m., which is their start time. So Dora and her brother Kyle started doing yard work at 11:45 a.m. What if Dora and Kyle spent 15 minutes doing yard work and then they stopped for lunch at 12:30? What time would they have started doing yard work? So it's the same idea. You start, this is their end time. So you have to go backwards 50 minutes to figure out when they started because this is the end. So back 50 minutes, if you go back 30 minutes, that would take you to noon. And then 50 minus 30 is 20. So 20 more minutes back would be 11:40 a.m. So when I'm trying to go backwards, they couldn't go back a whole hour in this one because it was only 50 minutes that they were doing yard work, but I went into the next easiest to think of increment. So, a lot of times the easiest time for us to think in terms of time is in 15-minute increments or 30-minute increments or 20. Something that's nice and even. So this one I went back 30 minutes because that would be a half an hour. And then I had 20 minutes left over. They still had to go backwards. So I had to go backwards from there and figure that one out. Turn to page 692. Here's another one. Ben started riding his bike at 10:05 a.m. He stopped 23 minutes later when his friend Robbie asked him to play kickball. At what time did Ben stop riding his bike? So this one gives you the start time, how long it took, and you have to figure out the end time. So you need to figure out what time he finished riding his bike. So I need to use the start time, which is 10:05 a.m. Remember, a.m. is morning and p.m. is afternoon, and that's really important when labeling your time. And I need to know how long he rode, and that was 23 minutes. And how am I going to use this information? I am going to add 23 minutes to his start time. So think of it as he's like fast forwarding in time. He's time traveling to 23 minutes in the future from when he started. So if it says he started at 10:05 and he went 23 minutes. So I'm going to go in increments of 10 because they actually measure the 10 out by 5s for me. But I can do 10s and then 3. So 2 10s and a 3. So I can go, that's 10 minutes. Then another 10 minutes. So far that's 20 of our 23 minutes. And then I can do 3 more minutes. So 1, 2, 3. Oops, it's right here. So that's 3 minutes. So that's all my 23 minutes are up here, which tells me that's 10:25, 10:26, 10:27, 10:28. So the question at the bottom says, how did your diagram help you solve the problem? It really just helped us see the jumps in time. So I'm not gonna have anything right there. Just kind of understand that this timeline helped us see how far in advance to go. I counted by 10s because that was kind of an easy way to count. And then I added the 3 left so I could make 23 minutes altogether. And that jumps me up from 10:05 to 10:28 is 10:05 plus 23 minutes. Alrighty, now I'm on page 693. It says Evelyn had dance class every Saturday, has dance class every Saturday. It lasts 1 hour and 15 minutes and it's over at 12:45 p.m. At what time does Evelyn's dance class begin? So they give you the end time and they tell you how long it is and you got to figure out the start time. So I got to figure out when her class starts. Next, draw a timeline to show the end time and the elapsed time. Now, the elapsed time would be the hour and 15 minutes. Because that's how long went by. And remember, elapsed time just means how much time went by. So if she ends at 12:45, let's see here. Here's 12 and here's 1 o'clock. This is broken into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sections. Wait a minute. Yep, 12 sections. It's kind of weird. Okay, so I'm not gonna really worry too much about exactly where this is, but I'm just gonna kind of put in some checkpoints here. So halfway in between would be here, I think. Yep, and I'm gonna say that that one is 12:30. And halfway in between, I see why now, 12:30 and, oh, sorry, didn't realize you couldn't see that, sorry. What I'm doing right now is I'm writing in some checkpoints to kind of help me see where the hour divides up. Because I know that the class is over at 12:45. So here's noon and here's 1 o'clock, but here's 12:30 is in the middle. So in the middle between that would be 12:45, because that's halfway in between 12:30 and 1 o'clock. Okay, so here's her end time. I'll label that so I don't forget. And her class was 1 hour and 15 minutes. So I'm gonna go back a whole hour, okay? And you can come over to this side and kind of do the same checkpoints so you can see how it compares on this side. So halfway between 11 a.m. and 12 a.m. or 12 p.m. noon is 11:30. That's kind of weird. And halfway in between that is 11:45, and halfway in between these guys is 11:15. So that kind of helps us break it down into 15-minute chunks, which is helpful too. Because this one, it says it went by after an hour and 15 minutes. So by putting it in 15-minute chunks, that kind of helps me see that a little easier. So I'm going to go back a whole hour, go back in time an hour. So I'm going to jump from 12:45 to 11:45 because I didn't change how many minutes there were. I just changed the hours because it was only 1 hour. So I'm going to go from here to here. That's 1 hour. And then it's an hour and 15 minutes. So going back 15 minutes, 5, 10, 15. Tells me that her class started at 11:30 a.m. Then it said, what if Evelyn's dance class started at 11 a.m. and lasted 1 hour and 25 minutes? At what time would her class end? So describe how this problem is different from problem 1. Well, this problem's different because they give you the start time and you figure out the end time, whereas this problem, they give you the end time and you had to figure out the start time. So it's just you really have to pay attention to what they want you to find. So this one, if we're trying to figure out, it doesn't want you to figure out the end time. Yeah, so let's see here. If it starts at 11 o'clock and it goes an hour and 25 minutes. So an hour fast forward would be noon plus 25 more minutes. Well, noon plus 25 minutes is 12:25 because you start at 0. So that would be 12:25 is when her class would end. So the main difference between these two problems is, like I said, this one gives you the end time and you figure out the start. You had to work backwards, go back in time. This one, it gave you the start time and you had to move forward in time to the end time. Figure that one out. Beth got on the bus at 8:06 a.m. 35 minutes later, she arrived at school. At what time did Beth arrive at school? This one I'm just going to show you how to do with just math instead of using the number lines. You can use the number line if that really helps you. But this one you can also just use more like a standard problem setup. So they start with 8:06. And 35 minutes later. So I'm going to put the 35 under here because this is the minute side. So minutes over here, hours over here. And I can add those together. Now if this ends up being more than 60, then I have to carry it over to the hours section. But if it stays under 60, it can stay the way that it is. 35 plus 6 is 41. And that's less than 60, so it can stay the way that it is, which means I don't have to add another hour over, so I can keep the 8 the way that it is. So 8:41 a.m. is the time she got to school. So that one was, again, starting with giving a start time and then moving forward in time 35 minutes. Lyle went fishing for 1 hour and 30 minutes until he ran out of bait at 6:40 p.m. At what time did he start fishing? So this one gives you the end time and you have to go backwards, okay? This one, it might be better to use the number line for this one. But you can also use just math for it too. So if he ended at 6:40 a.m. and you go back in time, so you subtract an hour and 30 minutes. Then I can add these two together. So, oh, nope, subtract. Just kidding. So I've got 40 minus 30. I've got 40 minutes, take away 30 minutes. That leaves me with 10 minutes. 6 hours minus 1 hour is 5 hours, which tells me p.m. His start time was 5:10. And if you were to work forwards, like if you do the start time and then you go forward in time how long he was there, it should end up right where you left off. So if I added an hour and 30 minutes to this, 30 minutes plus 10 minutes is 40. 1 hour plus 5 hours is 640. So that works out that way too. All right, coming over to 694. We got a few questions on this one. All right, Mike and Jed went skiing at 10:30 a.m. They skied for 1 hour and 55 minutes before stopping for lunch. At what time did Mike and Jed stop for lunch? So we're doing start time with the elapsed time, so we gotta figure out the end time. So I'm gonna do 10:30 a.m. And I'm gonna fast forward in time, so I'm gonna add time to that. 1 hour and 55 minutes. All right, 55 plus 30 is 85. Well, we can never have 85 in a minutes slot. It doesn't work out that way. So I'm gonna pull out 60 from this, okay, and carry it over here, because it's kind of like turning, I have 85 minutes, I'm gonna pull out 60 minutes, which is an hour. So I'm adding an hour to the hour side, which leaves me with 25 minutes on this side. Because like, it's kind of like if you think about mixed numbers, when we were adding and subtracting mixed numbers, if we added a fraction and the fraction of being bigger than a whole, then we had to kind of carry it over to the whole side, create a whole circle and put it on the other side. This works the exact same way. This is more than an hour, and you can't represent minutes as more than an hour in the minutes spot. So you had to take away an hour, pop it over here to save it for later, and then that leaves you with 25 minutes in your minutes spot. So then we had 10 hours plus 1 hour plus 1 hour is 12 hours. So that means the time that they stopped was 12:25. 12 hours, 25 minutes, which means that's p.m. They crossed over from morning to afternoon, which means they go from a.m. to p.m. That's your answer. Mike can run a mile in 12 minutes. He starts his run at 11:30 a.m. and runs 4 miles. Which time did Mike finish his run? Oh, this one's got a couple things to it. So if he can do 1 mile in 12 minutes, 4 miles, we'll do 4 times 12 to figure out how much he ran, how many minutes he ran. So I'm going to do 4 times 12. That equals 48. So he ran for 48 minutes. If he started at 11:30 and he went for 45 minutes, make sure you can see that okay. That would be 75 minutes, but again, 75 is more than 60, so I can't leave the 75 in that minute spot. I have to turn it, take out an hour, pop the hour over here. So I'm going to take away 60. I'm going to take away 60 minutes and turn it into an hour over here, which means I've got 15 minutes left over here. Okay. And then 11 plus 1 is 12. So the time that he finished was 12:15 p.m. Yeah, because he went from morning to afternoon. So that's your answer for that. I kind of like using the math method better than the timeline method because it just, I don't have to draw out the timeline that way. But if that is a method, you know, that really helps you out, by all means, draw a picture to go with it. There's just kind of a different way of approaching it too. You just have to really think through what they're asking you to do. Explain how you can use a diagram to determine the start time when the end time is 9 o'clock. And the elapsed time is 26 minutes. So again, this one you would just, you can show that a diagram would show you how you can go back in time 26 minutes. Or you can just use the math way, it's fine too. So the start time would be, you'd have to go backwards, which means you're subtracting. So that would be 9 a.m. minus 56 minutes. So I can't do that. I can't take 0 minus 56. So I'm taking away one of these hours, turning this into 60. Again, it's like taking the whole circles when we did mixed numbers, using one of those whole circles and breaking it into pieces. I'm not changing how much time is there. 8 hours and 60 minutes is still the same thing as 9 o'clock, okay? It's just kind of rearranging some things so that we can actually do subtraction the correct way. So 60 minus 56 is 4. Pull that 8 down because we're not subtracting anything down there. So 8:04 a.m. was the start time. So, and if it's asking you for a start time, make sure that your start time comes before the time you started with. If you were to get like 10:04 or something, that's later in time. You can't start later than you ended, so that doesn't make any sense. So make sure your answer makes sense with what the question's asking. Bethany finished her math homework at 4:20 p.m. She did 25 multiplication problems in all. If each problem took her 3 minutes to do, at what time did Bethany start her homework? So let's figure out how many minutes she worked. She was able to do 25 problems, 3 minutes per problem. Oops. So that equals 75. So she worked for 75 minutes and she finished at 4:20. So we have to go backwards. That would be 4:20 minus 75 minutes. Again, I can't do 20 minus 75. Subtraction does not let me do that. So I'm going to borrow an hour from here and add an hour to this one, which so 20 plus 60 would be 80. Because you had 20 minutes plus the 1 hour you borrowed, that's 60 minutes, which is where you get 80 from. 80 minus 75 is 5, 0, 3. 3 drops down because you're not subtracting anything over there. So your end time is 3:05 p.m. That's your answer. Vincent began his weekly chores on Saturday morning at 11:20 a.m. He finished 1 hour and 10 minutes later. Draw a timeline to show the end time. So he started at 11:20. So let's see here. 5, 10, 15, 20. Here's 11:20. Here's the start time. He finished an hour and 10 minutes. So an hour would be from 11:20 to 12:20. So that would be 5, 10, 15, 20 here. That's 1 hour and 10 minutes. So 5, 10. So that's 12:20 plus 10 minutes is 12:30. So he finishes chores at 12:30. If you were to do this with the math way, you would have 11:20. You fast forward in time, you add an hour and 10 minutes. It's 30 minutes, which is not bigger than 60, so we don't have to carry anything over. And then 11 plus 1 is 12. So that would be 12:30 p.m. All right, guys, this lesson's kind of tough because it's kind of thinking about, you know, we have to think of it as using mixed numbers because that's essentially what time is. Time is a mixed number. It's a whole number, it's a whole hour. So if your time is 7:15, that's 7 whole hours plus 15 minutes of the next hour. You know, when we did mixed numbers, it would be 7 and 15 out of 60. So times are just representations of mixed numbers, basically. So you have to kind of treat them that way too. If you got any questions about this, leave me a comment. This one gets a little confusing at times. Leave me a comment. I will respond and help you out as best I can. All right. Thanks, guys. Have a great day. Bye.